So, good evening all. My name is Amit. I am from NIT Trichy. I am going to present the basically wireless condition monitoring sensor. Why it is wireless? Wireless means the whole design idea. This is a kind of a block diagram for the idea. Idea in the sense like there will be a wall where and like this can be in the condition where you cannot have wired communication. You cannot just put the wires there. Why? Because maybe because of the safety critical system. Maybe like actually this idea came from the nuclear domain where the low range like radiation waste was there, nuclear waste, and we will put into the lead box, but we cannot have wired communication. But still we want to monitor that what kind of waste is there, where the temperature is increasing, where it is still radioactive, or like it will be radioactive, but whether it is lethal or whether it is dangerous. So the idea came from there, but there are still many applications where we cannot have wire communication because we have to drill it into the material. And once we will start drilling it, we will again playing with the structural deformity and all. So integrity. So the thing is, we cannot have wired communication. So, but still we want the communication. So what we will do? We have to pass two things. First, data should go one way, like one side to another side. Second thing is power should go from one side to another side. So before even start for the power, we should go for the data. So the experiments have been going on these three for the power transfer, for the data transfer. And so if we talk about the hardware will have like actually 2 piezoelectric patches, 3 piezoelectric patches, 4 piezoelectric, depending on the applications. So like 2 piezo means one will be transmitter, one will be receiver. 3 means the power and the data can be transmitted, but one by one. It cannot be transmitted simultaneously. So what will happen? One will be like when the power is transmitting, the piezo will take the power and like it will charge the inside battery or something like that. But at the second piezo will be responsible for the data transfer. So once the battery is charged and everything is done, then it will start the data. Most into the safety critical system or like suppose monitoring systems, we don't want continuous data, but we want at the regular interval. So there is enough time. Again, it depends on the application to application that there is enough time whether we can have like this like we don't want the 24/7 and per second data and all those things. We will have enough time to charge the battery inside. So these are the main components. Data will be there. So data can be a radiation sensor, data can be temperature sensor, data can be pressure sensor, same type of data is fine. Next is signal. Signal in the sense data cannot be transferred directly. We need to modulate it, right? And then amplifier, we need amplifier because these piezos will work on high frequency, and so and also there will be a solid metal block there. So it needs to transfer, right? The outside, no problem. Actually, outside we will put amplifier which is sensitive enough to take all the pick up from this one. But so outside amplifier will be there, and filter and processing circuit is there to make some sense of the data. So some applications which I am talking about is like glove boxes. If there is a glove boxes, we don't want any wired connection. We don't want to play with the like drills and everything. So best idea is to use that to have a wireless communication where the metal will do its part to protect everything into a confined environment, and like the data will be transferred. Okay, so some experiments is performed over the course of time under the project. Some experiments are being performed. So these are the 4 experiments. First is audio signal transfer. First is audio signal transfer. We transferred the audio signal. We see whether it can be transferred through the piezo or not. Second, we went for the like data transfer. Data in the sense we transferred actually the humidity sensor data. And the third we transferred about the text. But what we change into all those things, we changed the modulation technique. We seen how much cheaper we can go. We went through the outside this modulated output, do modulator. We seen how much like we can make it like we need not to put all the standard components and all the standard and costly equipments outside. Maybe it can be done using the cheaper components and the transistor based circuit, simple like Arduino based circuit. So this is all proof of concept started, and the last which is proposed for like show of this today is power transfer. So here the audio signal is transferred. How it is transferred? First of all, like the AM modulator was there, and we generated one signal from the mobile phone. So basically we generated a proper tone. We went from the standard, then actually we really got this data from the charge amplifier. And charge amplifier we have thought because at that time this whole piezo was behaving like a capacitive sensor, and the change was into that range, capacitive sensor and like that. So we got the suggestion that better to use charge amplifier, and it works fine. And then actually what is the next step? Next step, we put actually this whole thing into a high temperature oven. Okay, so like how much temperature, whether at the high temperature, like here the, what to say, the research was done from the temperature dependability, like how, whether it can be worked on the high temperature also, whether this communication is possible or not. Okay, but the problem and the limitations here we faced is like the power. Okay, inside also we need too much power, and outside also, outside we have enough enough power to process the signal, but again we will have the constraint inside the box, inside the confinement. We cannot have enough like infinite power. Okay, so this was the idea which went into last, that how to make it more efficient, more power efficient and all those things. The next thing went where we went through the digital signal. Okay, so digital signal, we actually took the DHT11 signal. We have done it with the digital DHT11 signal also. But then what we did, a simple thing, like the carrier generation was there, and then the modulation, and we put the digital data over there, and we transferred it. It was tested onto a different module, means different block of, it was putting into different block of metal. Also, different types of piezo crystals are being used. So these piezo crystals were actually made for the 400 degrees Celsius and all, like these connections, these wires, all these things are like, they have a rating up to the 400 degrees Celsius. So we connected, and then we changed the demodulation circuit also. It will be, I think, yes. So this is the data. This is the data what we got actually. So this was the digital inputs, and when we modulated, it was perfectly fine. Okay, so when we demodulated, we got our data back. So we just proved that we can actually transfer the data, and we are talking about 150 mm of the block, and that is iron block. Then we went through the number of material also, like aluminum and all those things, and we can see that it is possible the range will be different. It is possible, range in the sense, this like the clarity, the data clarity will be different, and it will be very, very easy if it is iron blocks, a solid block. And with the aluminum, we have seen, it is sometime it will miss the data. Sometime like at the high frequency, it might not work. Then we went through the text, and for the text, we went off the shelf components. And for that, you can see like there was a text like a generator, like Arduino will transfer the data, AM modulator using this transistor based circuit, and again we went through the metal wall. And so what is common between both the sides is piezo crystals. Piezo crystal was in this side also, that side also, but we are not so another thing when we are working with the piezo is the frequency range we are choosing. Okay, so this experiment was performed on the multiple range of frequency, on which frequency we are getting the better results, on which frequency we are getting the better resolution. And then we started experimenting on how to choose that frequency as the carrier frequency, how to generate that frequency like without using any standard components or something like that. How to, if some circuit is there with proper carrier frequency generator, then we have to alter the piezo according to that. Okay, and also sometimes the paste we are using for the piezo to paste it on the block, that also the thickness of the paste, like the glue we are using, that also affect this thing. So there are multiple parameters which needs to be addressed during this development. So you can see like it was pretty clear in the case of text also that it was working very good. Like we can just reduce the signal here. It was good. So then actually the main thing started. Main thing means the power, how to transfer the power. But there was always restriction because in the output we always get very less frequency. The less frequency means less power we will get. Most of the things will be absorbed by the block itself, right? And this is infinitely big block. We will consider it as infinitely big block so that it will absorb most of the frequency or most of the things. Very less thing will be passed through that side, right? So we have to find a component which can be capable of storing the power, and simultaneously it has to regulate it and supply some kind of sensor system inside the container. So with experimentation, we found out that that energy harvester. So energy harvester we have used ES300. So ES300 have the capability to take very, very low frequencies, low power, okay, and to store it into that inbuilt capacitor. Okay, once it is reached that it can give supply, it will not give supply first of all. It will just store the power. Once it will reach beyond a certain level, it will start giving the 3.3 volt continuously unless there will be it will go beyond a threshold level, below threshold level. So this so we found this component, and this component have actually the problem is very low current. But this component can be used in future to charge this supercapacitors and all. So we have to design one capacitor circuit or supercapacitor circuit which will charge these things, okay, using the ES300. But right now in this scope, we use ES300 and directly powered two devices which is very, very low power, ESP8266 and DST module. So we just made one PCB, we connected these two on the same PCB, very small module, and we transferred the data over the internet, over the Wi-Fi. Okay, so for the input side, we have used function generator. We generated one function, and because we want to transfer the power, okay, so we went through high voltage amplifier and we transferred. The problem is, we have to, again, the frequency, what frequency we should use. Okay, so then we went to go to and fro, and we found out that the frequency is a bigger challenge here, because different frequency, different power will be transferred. So we went through the finding of the resonance frequency for that block, and for that the COMSOL simulation has been done. Okay, so you can see this was the input frequency, the orange one was output frequency. Still ES300 is fine enough to store the data, and we got that peak, and that is a very good thing. We transferred the power there, that side. The thing is, we cannot store it. The thing is, at that frequency, if we use it continuously, it can supply it to the sensor system, but we cannot store the power. Okay, so this is the setup we made to check the blocks, the blocks frequency. The blocks frequency in hardware. It was designed, and it is made in such a manner so that it will be heavy enough so that it can simulate the infinitely long sheet. And this was the Siemens system to check that, and we got the frequency almost in the same range, and that frequency we used to transfer. This was the actually sensor system which I was talking about, along with the ES300, and this is the complete setup with the high voltage amplifier and everything. And this is actually the final output, where we put everything on the ThingSpeak. So if ThingSpeak is possible, then everything is over the cloud. It is possible. It is just a proof of concept. But if this thing is possible, means the transfer of power is also possible. Thank you.